Go ahead. Count us down. Wait, are you recording?
All right. Yes.
Hey guys, this is the Nerd Herd. We're going to go over Chapter 7, Decimals, Real Numbers, and Proportional Reasoning. I'm Hope Windle.
I'm Danielle Gillham.
Chris Crowe, once again at your service.
Okay, hey Danielle, to start us off, could you show us how to turn a decimal into a fraction?
Yes. Okay, so let me try my iPad. So what you're going to be doing is, okay, let's see. So if you have a decimal that is, say, 0.2, then you're going to multiply by 10.
Chris, you can turn your volume down. Sorry, Danielle.
You're good. And then same with the hundreds and the thousands. So this number 0.036 ends in a thousand spot. So you're going to multiply by 1,000 and you get 36. So then you're going to break down 36 and 1,000 and find the least common multiple, which is 4. And then 36 divided by 4 is 9. And 1,000 divided by 4 is 250. So 0.036 equals 9 over 250 as a fraction.
Awesome.
Very well put together.
How do you break a fraction down into simplest form?
That's a very, very good question, Hope. So to break a fraction down into its simplest form, you need to find what we've gone over before as the GCD, which is the greatest common divisor. And to do that, you simply look at the different numbers that are divisible by both the denominator, which is the bottom number, and then the numerator, which is the top number. So in this case, we have 225 over 1,000 equals 9 over 40. How do we get that? Well, we divide 225 over 1,000 by 25, and that's because 25 is the greatest number that can divide into both 25 and 1,000. And once you finish your division, you get 9/40.
Okay, thank you.
Very good.
Now, Danielle, can you explain to me how to find what number to divide the fraction by in order to simplify it?
Well, I'll do that, Chris, and I'll do it by using prime factorization. We're going to take our numbers, 225 and 1,000, and we're going to see that the numbers that they both have in common are going to be 2 5s, and that's going to give us our 25. So we take all these other numbers away, and we're going to divide 225 over 1,000 by 25, and that's going to give us 9/40. And if you go back to our numbers before that we had, like you'll see that what's left over after you take away the 25 is 9 and 40. So that, I think that's a pretty cool little trick to use if you don't just know off the top of your head what number to divide by. So let's go on to some graphing. So Chris, how would I graph the equations y equals x over 2 and y equals negative x over 2?
Once again, another really good question, Hope. So in this case, we have our graph right here. And the way this works is you have to identify what each of these variables represent. So y obviously is going to represent the y-axis or the overall equation. And then we have to find out what the x and the digit 2 represent. As you can see by the line, we've gone over 2 and up 1. So in this case, we can say that, for example, people can increase their longevity by eating healthy by 2, or let's say 20 years or so. So we go over 2 and then up 1. The up 1 is simply represent the increase in longevity.
Okay,
and as far as y equals negative x over 2, it's the same concept, except it's going down, it's decreasing. So in this case, people can decrease the amount of heart attacks they might receive in older age, so long as they restrain themselves from unhealthy activities like smoking or drinking or just consuming things that aren't healthy for your body.
Absolutely.
And negatives in this case will represent going downwards or going to the left, which is also the negative section of graphs like the one you see here.
Okay. Thank you.
Now, I have a question for you, Hope.
Okay. Is this it?
Can you explain what y equals x squared will look like on the graph?
Sure. Let me try to get my annotate tool up here so I can actually draw on it, because I couldn't find a cool parabola looking thing. Let's see. I'm going to draw. Okay. So I'm going to go down here. We're going to start our x. And whatever happens on this side of the graph is going to also happen on this side of the graph. And if I were doing this properly, it would actually be even and not all wonky like that. But basically, so whatever happens on one side of the graph is going to also happen on the other side of the graph, because you're having your x squared. So it'll be both positive sides of the y-axis. It's like a mirror. So I think that's a pretty cool little tool there. Okay.
Okay.
Now let me get out of this annotate thing, and I'm going to go on and I'm going to ask Danielle, how would I graph y equals 10x?
Okay, so to graph y equals 10x, your x is going to be your 1 or your 2, whatever you put in its place.
Yeah.
And then every time you have the number that's in its place, you multiply it by 10. So if we had a 1 and a 10.
Why did I go backwards?
I'll go back. Okay.
Technology, it's finicky.
I don't know why that happened. My hands were over here. Anyway. Sorry.
So right here is your 1, and then you have your 10 right here.
Mm-hmm.
And then your 2 is on this line, and then it's going to be on, line 20.
Oh.
And so you'll just,
I like that. So it just keeps going up and up.
yeah.
Nice.
And then 3 is 30, and so on. It's pretty easy.
Very nice. That is an easy one. I like that one.
Yeah.
Was my favorite.
Yeah, mine too. I'm
All
gonna
right,
wait.
Hope, I got a question for you. Enough
Sure.
with these graphs.
Did you clear your annotation? Sorry.
Oh, yeah.
I don't think I can. Oh, awesome. Okay.
Yep.
Let's go.
So how would I convert a fraction into a percentage with using shapes?
Okay. Well, first we're going to look at all of our little shapes here, and we see that we've got, 3 full blue blocks, but we've got one that's in half of a blue block. So we are going to just pretend that all of these are divided into 2 like this, and that's going to give us 18 little places. And then if we do, so we have 3, so we have to multiply that by 2, which would give us 6, and give us plus 1, that'd be 7. So we'd have 7 over 18. And then to find it in a percentage, we would have to say P out of 100, because percent is out of 100. And then to find the answer to that, we would have to multiply 7 times 100, and then we'd have to divide that by 18. And that would give us our P, our percent, which would actually end up being like 38.888888889. So it would be about 39% or 38.9%.
Okay.
And Chris, like, what do you do to find the fractions of those halves shapes?
Well, once you have the fraction, once you have all of your highlighted or shaded in regions, and once you've split all of the equally divided shapes, so as you see here, we've got X amount of squares that have been divided into. Now you have to remember, these only work with equal shapes. So if one triangle is smaller than the other, it's not going to work. This method won't work. So once you find the fractions of the halved shapes, so in this case, we have the full 18 pieces. If you imagine all of them have been cut into equal sized triangles, you will have whatever amount you have shaded over the full amount. And once you do that, you're going to take that fraction and then you are going to multiply it by 100, I believe, because 100 will represent the whole. Like I said, each half will represent 2 equal pieces in its own right.
Sorry, I was just kind of,
Okay.
it froze on me.
Now, I have a question for you, Danielle.
Okay.
Can you tell me what is the percentage and fraction of the colored part of this figure, what looks like a yin and yang symbol, a very well drawn one, I might add?
Thanks. So this one's really easy just because there's only 2 parts. You have your 1 part and your 2 part, and they're equal. So this one's going to be 50%, and this side's going to be 50%. So you're going to have
balance.
2 sections.
So this is the one we've gotten so far.
Huh? What'd you ask?
It's the simplest one we've gotten so far.
Yeah.
Yeah.
I would believe so.
It seems tricky though because it doesn't look even at first because it's all curvy. And I think that would be a good question too for maybe a student would ask, what if the lines are curvy? You know, because even though they're curvy, it's still even. All right, after you clear your annotation.
2 squares.
Right.
All right.
Okay.
All right, Hope, I've got a question for you. What percent of the hexagon does the trapezoid fill in?
Okay, well, you can look at the hexagon and see that it would fit in 2, like there's 1 and there's a second trapezoid. So like you were saying, if there are 2 pieces, we would divide 100 by 2, and that would give us 50%. So 1 hexagon is 50% of the trapezoid. And Danielle, what percent of the hexagon does the triangle cover?
So the triangle can be broken up into 6 different pieces, or the hexagon can be broke up into 6 different triangles.
Really good
And
slide.
so you're just going to do your 100% divided by the 6 triangles. And so it's going to be 16.67%. Each piece will be 16.67%.
Beautiful.
Very well done.
Thank you. So Chris, what percent of the hexagon will the blue rhombus be?
That's pretty much the simplest question that can be asked once we've gotten the wonderful explanations from my 2 previous partners. Just like how Hope and Danielle have figured out their shapes, the blue rhombus fits into the hexagon in 3 equal-sized rhombuses. So following the same method that Danielle has displayed for us, we're going to take those 3 rhombuses, we're going to have it divided by 100, which will equal the 33.333333% that they represent. And that will work for all of the remaining shapes, the tan rhombus, the square. It will work for any of the shapes involved when finding the percents of them compared to the hexagon, which represents our whole.
Okay, thank you.
Of course. Now, Hope, or rather, no, not Hope. You've already had your time in the sun. Danielle, say I have a friend named Leroy, and he's selfish. So Leroy has 8 pieces of candy, and he gives 4 pieces to Alyssa, even though she doesn't deserve them. What percentage of Leroy's candies did he give to Alyssa?
So this is the whole method of finding the percent given A and B. What percent P of B is A. So Leroy gave 8 pieces of it, or has 8 pieces of his candy, but he gave 4 pieces to Alyssa. That was quite generous of him. So this one's easy just because of the fact that you have the numbers 4 over 8. And so then it will break down to half. And then we all know that half is 50%. So Leroy decided to keep 50% and give away 50%.
That was so nice. I want to be friends with Leroy.
Now, Hope, enough with the candy and the diabetes. Let's go on to some broccoli. If you've eaten 40% of your veggies and your mom says you've only eaten 2 pieces, how many pieces did you start with?
Okay, cool. So we know we've started with, or we know we've eaten 2, and we know that 2 is going to be 40%. So we know percent is 100, and we know that we have 40 of 100. So what we're going to have to do this little equation. We're going to cross multiply and divide. So to figure this one out, we can say 100 times 2 is 200, divided by 40 is going to be 5. So B is going to be 5. We started out with 5 pieces of broccoli. I think that's fair since we ate 4 pieces of candy, you know. Okay.
Half the balance.
Oh, yeah.
Chris, is division the only way to solve percent questions?
That is not the only way to solve these types of questions. You can do any sort of mathematic method. Division is simply the one that is most often used when dealing with percentages, but conversely, multiplication is used just as much, because you'll have to multiply a certain amount by typically 100 since it represents the whole, but that can vary depending on how much of something you actually have. How many pieces of broccoli, how many pieces of candy, how many tacos you might be having for dinner. They all depend on the method needed to solve division, multiplication, addition, subtraction, whatever it might be.
Okay, cool.
Of course. Now, Danielle, what is a proportional reasoning scenario?
So now that you mentioned tacos, I really want Taco Tuesday, but a proportional reasoning scenario can be used for, like you said, buying tacos. You need to know how much you're going to need. Say it's 99-cent taco night. You're going to obviously need 99 cents plus the tax for each one. A proportional reasoning is basically just the reasoning based on relations of proportionally. Yeah. And it shows ratios, fractions, and then you use it in everyday life when you're buying gas and filling up your tank, recipes for if you need a bigger quantity, sharing candy or broccoli, and then if you're getting a raise. So.
Very nice. Very well explained.
Thank you. Do what?
Oh, I said that is a good one to think about the raise.
Now, Hope, what does K represent in the equation y over x equals K?
Okay, since we just passed Thanksgiving and we're coming up to Christmas, I thought it would be good to talk about turkeys. So K is going to represent our constant in our proportional reasoning. Like you were saying before, it's good to know about things like that. So we're going to look at our little table here that I made. And I'm actually going to pull up my annotation tool so I can write some things. Let's see. Okay, so you have your cook time, and we're just going to say, we're going to start with the first thing that we have here. We're going to write 160, and we have it over X. So we're going to put our 8, because we have our little things right here that tell us on the table. Our turkey weight in pounds is going to represent our X. And if we were to look at it on a graph like we had earlier, it would go across. And our cook time is going to go this way. Well, to find K, our constant, that's going to be, what does that out to? 20. Okay, like 8, 20. Yeah. So basically what K is going to represent is roughly about 20 minutes per pound cook time. So whenever you're doing a proportional reasoning, if you look at this table, you can see that no matter which X and Y you have, whenever you divide 280 by 14. That is also going to give you 20. And again, this isn't an exact thing, it's just like a rough estimate. So when you're actually cooking a turkey, I would just use a meat thermometer to make sure that your meat is actually good for you. Just go off this constant thing here.
Better play it safe.
Okay. Yeah.
Oh, your math sounds so concrete.
Yes, exactly. Well, that's what the proportional reasoning said. Okay, so Chris, how do you go about creating a one-to-one proportional question?
Well, it's very simple. You've basically answered my question for me, Hope. It's a matter of simply setting up. Now, this is one of the ones you would describe as a full-on word question, whether you're making a turkey, or you're creating a mug cake, or you're making lava cubes. You have to set up the amounts of the ingredients you might need. You have to set up the amounts of cookies in question that you might be making, for example, when dealing with a lava cube. And then you have to set up how many of those ingredients are proportional to how many of those cookies, 1 to 1. Now, the ones won't mean one of each. It depends on, if you're making 12 cookies, you're going to need at least 6 lava cakes. Cubes, not cakes. Those are bigger. The 1-to-1 just means this amount is required for this amount. And that can go for any kind of topic, any kind of subject whatsoever. It's simply a 1-to-1 combination.
Okay, cool. All right, guys. I think that is going to wrap up our lesson on Chapter 7. And thanks, everybody, for watching, and thanks for learning with the Nerd Herd.
Thank you.
Thank you very much, you guys. You have a good night, and please have a fun, safe holiday season.